Mostly, classes are the syntactic sugar in the JavaScript. Unlike the other programming languages, JavaScript doesn't contain proper classes. JavaScript classes use the prototype-based inheritance by using constructors. Let us start with this boilerplate code. There is a user object and a function, addAge, that console logs user's age from their date of birth. Let us execute this script real quick and check what it does. As expected, date of birth of the user is converted into age and age is console logged. Time to define our use case. Say, we get a list of users from an API. Let us cook up some data to mimic the same by creating a list of users and changing the date a little bit. Now, let us use map function to iterate over the list of users and call addAge iteratively. The script should output age for all 3 users. Let us do some cleanup. Before introducing a little bit of complexity in the requirement, let us extract the data and the function onto individual files and import the same in index.js. Arrow function notation is cool and functional. So we will just rewrite the function as an arrow function and export the same using module.exports. We will now introduce some irregularities in the data. We will introduce blanks for language for a user and have the language property itself removed for a user. Also, we will have blanks for date of birth for another user. Let us execute the script again and check the output. There we go. We have got a NaN for second user. NaN means not a number. This is because we have replaced date of birth for the user with blanks. We will rename addAge into calculateAge for uniformity and better clarity. And we will consider adding a new functionality, this time for the language property. Check language will just return true if the language is English. And we will go on to invoke the function from index.js to console log the output. Alright, we got the desired output. Time to add some validation checks. Number 1. If the date of birth is invalid or missing, then skip that user from being processed. Number 2. If the language property is missing or blanks, default it to English and still process the user. Now comes the dilemma. We have made the code somewhat modular. Now, it is easy to read and comprehend, but where do we add the validation checks? If we add them on to index.js, on the longer run we end up writing a ton of script files calling the utility functions, so we end up maintaining validation-related code across files. If we write the checks in the utility functions themselves, again code duplication will happen when we write additional functions using the same data or properties. Is there a better way? Yes, we do. That is to write classes and keep the data structure and validation closer to each other. We can create a new folder to hold all our class files. But here it is more apt to name it as models so that we can have all the entity objects here. Let us now write a class, shall we? Firstly, let us create the structure, the class body, export statement and default constructor. Let us start adding the properties in constructor. This notation allows us to have the instance of the property in scope of this JavaScript class. When the class is instantiated, it is params that contains actual data which is brought into fields with this notation, the context of this class. JavaScript is so forgiving that it doesn't worry about the comma that I have used instead of a semicolon. Lastly, we will add a shell validate method, which is the ideal place to keep all validations related to this entity, so that in future there is one place to check, change and maintain all validations for an entity. We will add now the first validation for language property to check if it is blanks and console log the same, if so. Once we create an instance of the user model with new keyword, we should have access to all the properties and functions in the class. Let us now execute the script and confirm that we are able to see the log for blank language field in the console. One of the users have language as blanks, but another user is not having the property in the first place. So, if we add another if condition to check the existence of the field, we will be able to cover the other case as well. But how do we initialize the field to English? That is so simple. Just add an OR notation in the property itself to initialize it to a value. That's it. Now the field will be initialized if it is blanks or non-existent in the source object. Next, we will do the same for date of birth field. First to check if the field is existent and then to check the format if it is really a date. We will make the validate function return Boolean responses so that we can use the response in index.js to skip the user from being processed. Also, another requirement was to manipulate the object to add an additional field, age. Let us do it by adding this property to user model in index.js. . Now you are closer to the requirement. Code is cleaner and you filter users without valid date of birth and initialize language to English. All good? No, we can do better. Throwing an error is a lot better than playing around with Boolean values. Nowadays, the error object often has a code in it. We don't have an error code in default error interface provided in JavaScript. Let us create a validation error class extending error interface and create a custom error interface to throw when required. A custom method, print message, can be really handy when we need to print out the error on console. Let us now throw the errors rather than using Boolean returns. And while doing so, let us provide an object with error code, error name and error message for better clarity. Returning Boolean can now be safely removed. We should now figure out how we are going to use the error object to retain the functionality we had with Boolean return. Try catch block can be used to catch the errors thrown by the called functions. We can wrap the functionality into try block and catch errors, which are instance of validation error, and print the error message with error code. Unknown errors are then caught and thrown as is. That's weird. Something is wrong. Let us debug and fix the same. This should be a small defect. There it is. It should have been this dot and not params dot. Now it should work fine. And it does. How cool is that? We can change data a little bit to cover other scenarios and prove that the error messages are thrown appropriately. Let us do a little refactoring of the literal in error message. Alright, we have completed the objectives now. Let us clean up the last unused bit in the code. Check language and its references can now be safely removed.